Hello everyone, and welcome to another tutorial on MINEDW, the 3D groundwater flow code developed by Itasca. This time we will address pumping wells, also known as vertical pumping drill holes. We will briefly explain what they are, their main features, and how to include them in MINEDW simulations. Pumping wells are vertical boreholes that can have the purpose of depressurizing or draining a certain rock mass. To determine its potential effectiveness, it is recommended to carry out a pilot pumping test beforehand to understand how the hydrogeologic system reacts to the extraction of groundwater. Pumping wells can be between 30 centimeters and 2 meters in diameter, and inside them pipes can be installed or not. The annular space between the ground and the pipe can be filled with filter material. The depths of these wells can be very diverse, from 30 to 40 meters for wells inside a pit to more than 300 meters for wells outside of pits, aimed at providing barriers to lateral recharge. Pumping wells are expensive dewatering structures. To have an idea, a properly fitted pumping well with a depth of some 300 meters can cost approximately $750,000, including the engine, pump, and discharge lines. This is why special care must be taken when it comes to its design, especially its location and the materials it is going to pass through. In low permeability rocks, where the flow occurs through fracture areas, this becomes even more relevant. Therefore, the correct simulation of the pumping wells is a very important step when it comes to the well construction project. MINEDW simulates pumping wells by incorporating the groundwater extraction effect to a node at the pump position. The screen pipe is simulated by generating a very high permeability unidimensional element, thus simulating the effect of drilling. Three conditions can be imposed on pumping wells: constant flow, the user enters a flow rate which will be obtained in the simulation; target piezometric level, the user sets a piezometric level and the model calculates the flow rate required to reach it within the pumping well; or constant flow with level restriction. The user imposes a flow rate until the piezometric level reaches a defined level. When the water table reaches this level, the well will be disconnected to prevent the well and pump from drying out. To insert pumping wells in MINEDW, we have different methodologies. However, in this video we will review one option, which is quite fast when the location of the well or wells to be simulated is known. This is done with an ASCII text file that contains in its first line the number of wells to be inserted in the model, in this case just one, and then in the following lines we will have the name of the well to be inserted and the local coordinates of the pump location. Having the file with this format ready, we open the menu BC Pumping Wells in MINEDW, where the menu will be empty since the model does not have any wells yet. And then we open the file with the Create option. Once selected, we will see that the pumping well was created, assigning the closest node and, by default, the constant flow condition. In the menu, we assign the length of the screen from 625 to 675 meters, the operational condition, in our case pumping rate with LPE, with level descent limit of 5 meters above the pump, that is to say at 630 meters, to ensure that the pump doesn't dry out. We will click OK in the pop-up window. We will select No, since the model mesh can be modified, and now we can see the pumping well by loading the List Boundary Conditions Pumping Wells menu, where the pump and the trace of the pumping well will be seen. Once incorporated, we configure the pumping flow to 200 cubic meters per day from January 2001, and we stop it a year later. We click on Apply and OK to then create a model dataset and run it. Once the execution of the model is finished, we close the execution window, load the results, and with the different plot options, we can see how the model is affected by this pumping well. For example, by making a section in the pumping well with a plane tool. Now we see a distribution of pore pressures that is constant throughout the year 2000 and then modified in 2001 when pumping begins, generating a decrease in pressures. Which we can see with a more limited color scale, observing how pressures drop with pumping. After stopping the well operation, the pore pressures recover again. Well friends, I hope you have noticed that it's very easy to implement and simulate pumping wells in MINEDW. We hope you have found this tutorial useful. You are invited to subscribe to the Itasca channel, and we hope to see you visiting again soon when we release another video. Thank you.